This leaf has no smell, no bitterness. People say it sells hospital bills. Hello everyone, welcome back to Kitchen Chemistry with Imabest. Today we'll be looking at this leaf, the chemistry behind this leaf. So this leaf is called hospital tufa. In traditional practice, it's believed to support health and reduce frequent minor illnesses. Chemically, this leaf contains chlorophyll, antioxidants, and aromatic compounds that may help the body, but it doesn't replace medical care. Yeah, and there are other nutrients present in this leaf. So we'll be looking at the chemistry behind this leaf. Don't walk past this leaf. This leaf is very good and is so nutritious. Yeah, it contains so many nutrients in it. Let's see. This leaf is over 80% water, which means most of its nutrients are already in soluble and bioavailable form. You know what that means? They easily dissolve in your digestive tract and efficiently absorb into the bloodstream. And you know, digestion is very good for the body. If your food doesn't digest well, you know what that means? It can cause so many things medically. Yeah. This leaf is dominated by chlorophyll. Yeah, because of the greenish color you see there. Yeah. So let's look at this structure, the chlorophyll. Take a look at that structure. Look at it very well. The active site here is number one is the magnesium ion that is at the middle. This magnesium is what makes the chlorophyll absorb light very well. Now the second active site there is the chlorine ring. That is the porphyrin ring. The ring that is that aromatic ring, yeah, that has a magnesium atom inside at the center. Then the 4 nitrogen atom. So this 4 nitrogen atom stabilizes this magnesium ion, yeah, through coordination covalent bonding. That is, they share electrons. This leaf also contains flavonoids. Yeah, these are silent protectors. Yes, this one is non-bitter flavonoid, not the bitter ones like the kaempferol and the luteolin. Yes. Now, if you look at that structure, that is a kaempferol. Yeah. If you see the structure, you see 2 aromatic rings, 2 benzene ring. Yeah. Ring A and B. That is the benzene ring. The ring, the one that is at the middle, is the recycling ring. That one that is carrying oxygen atom. Yes. Then you also see a ketone group. That is the carbon to oxygen double bond. Then we have some active sites in this structure. If you look at that structure, you see OH group. That is a hydroxyl group that is attached. There are different positions. Yes, if you look at it very well, you see the OH group at position 3. Yeah, position 3, position 5, position 7. Then you check the ring B, the one at position 4. Those ones are the active sites. Then we also have, if you look at the middle ring, the heterocyclic ring, the double bond that links carbon 2 and 3. That particular double bond is one of the active sites here and are very important for its antioxidants and also enzymatic inhibitory activities. So let's quickly look at the luteolin ring. It's almost the same as kaempferol via the structure. You see the 2 benzene ring and the middle heterocyclic ring. Then the active site in this structure is the phenolic hydroxyl group. You see those hydroxyl group that's attached to the benzene ring, both ring A and B. Yes, for ring A, you see it at carbon 5 and carbon 7. Then for ring B, you see it at carbon 4 and 3. Yes, those OH groups are the active sites in this structure. Then the conjugated system, you'll be seeing carbon to carbon double bonds. Those conjugated system are still parts of the active sites in this structure, and that's what gives it antioxidants, anti-inflammatory and anti-tumor activities. We also have other features like the carbon to oxygen double bond you're seeing there. Yes, that is the main site for interaction with protein. The OH at position 5 and 7 contribute to the overall antioxidant potential and also main target for structural modification. Yes, that means if we work on this structure at those positions, that is position 5 and 7, if we substitute or replace those positions with maybe an alkyl group or an acyl group, wow, it may enhance bioavailability. Yes, yeah. It means we may have a better activity aside the antioxidant properties. Yeah. So this leaf also contains vitamin C. And what does vitamin C do to the body? It enhances what? Iron absorption. Yeah, that is redox chemistry. Yes, but reduction and oxidation is always so confusing to students. Yeah, I'm going to teach this in one of my videos. Yes, where this one denotes electrons and becomes what? Oxidized. The other one takes electrons and does what? And reduced. Takes electrons and get reduced. That was interesting but confusing. Yeah, so what happened between vitamin C and iron is that vitamin C donates electrons to what? To the iron. It reduces that ferric ion to what? Ferrous ion. That is the Fe2 plus. Yes, it reduces this ion to this form, the form that is much easier for your intestine to absorb. Yes, which is very good. So eating isn't the problem, but how your food digests is what is important. So you shouldn't ignore this leaf. It has vitamin C inside and it's very good. This leaf also contains folate and mineral ions. Mineral ions like F2 plus, the magnesium plus, the calcium plus, and the potassium plus. Yeah, the iron 2 plus you are seeing there is in reduced form. Like the 2 plus means has taken 2 electrons and becomes what? Reduced. The magnesium 2 plus also means the same, taking 2 electrons and become what? Reduced. All these mineral ions in it. What are you still waiting for? The potassium showing just a positive sign on top, that is 1. And you know in mathematics you cannot be writing 1 and yeah, that one is invisible. Yes, so the plus means it has taken what? 1 electron and becomes reduced. One leaf has all these things. What are you still waiting for? And the folate is just vitamin B9. The synthetic one is what? Is the folic acid we've been taking. Folic acid. Yeah, the ones that is used in our supplements and fortified foods. Yes. That routine drugs they like giving pregnant women. Pregnant women, what are you people still waiting for? This folate is very good for children. It prevents severe birth defects. Yes, most of these defects you see in children, if a child lacks vitamin B9, that child might have a severe birth defect. Yes. So the folate, the natural one, is in this leaf. What are you still waiting for? Yes. This is the folic acid you've been taking now. That is it. Please, if you're a pregnant woman, don't miss this leaf. Yeah. You can squeeze it. You can squeeze this leaf and drink every morning. Or you can cook it. If you cannot drink it, the leaf is tasteless. So yeah, it's not bitter. You add it to your fluted pumpkin and probably water leaf. Yeah. Eat it as soup. Or you use it and make sauce. You can use fish. You add your fresh tomatoes. And you make your sauce and eat. You use it and eat your white rice, or you boil yam or plantain. There are so many ways of consuming this leaf. Please, this leaf to be very good for your child, for the growth of your child. Please. So anytime you see this leaf, grab it immediately. It's very good. Yeah. This is Kitchen Chemistry with Imabest, where we don't just eat food, we understand the molecules.